Welcome to Daily Papers, the podcast where we break down the most interesting new research so you don't have to.
Today, we're talking about the next evolution of AI. You know, we're all used to AI assistants like ChatGPT that can answer questions or write an email. They're like incredibly knowledgeable librarians.
Right, you ask them a question, they give you an answer based on the books in their library. Very smart, but also a bit passive.
Exactly. But what if that librarian could not only find you a book about Italy, but also book your flights to Rome, reserve a hotel, and create a custom itinerary for you? That's the leap from a standard large language model to what this paper calls Agentic AI.
So it's an AI that doesn't just talk, it does. It's an autonomous problem solver. This paper, a CPU-Centric perspective on Agentic AI, from researchers at Georgia Tech and Intel, dives into what it actually takes to make these action-oriented AIs run efficiently.
And they found something pretty surprising. We always hear that AI is all about GPUs, those super powerful graphics cards that do all the heavy lifting. But for these new agentic AIs, that's only half the story.
What's the other half?
The humble CPU, the central processing unit. It's the workhorse processor that's in every computer. While the GPU is doing the complex thinking for the language model, the CPU is the one handling all the actions, or what the paper calls tools.
Tools like what?
Things like performing a web search, running a piece of code, searching a database, or even just reading a file. All those practical tasks are handled by the CPU. And here's the kicker. The researchers found that processing these tools on the CPU can take up to a staggering 90.6% of the total time.
Wow, so 9/10 of the waiting time for an AI agent might have nothing to do with the glamorous AI model itself, but with the basic tasks it's running on the CPU.
Precisely. Everyone has been laser focused on optimizing GPUs, but for these new agentic AIs, this paper argues that the CPU is a massive and largely overlooked bottleneck.
So, how did the researchers figure this out? Did they just test one type of AI agent?
No, they were very systematic. They realized that not all agents are built the same. So first, they categorized them. One category is based on the orchestrator, basically who's in charge. Is it the AI model itself making decisions on the fly, or is it a computer program telling the AI what to do step by step?
Like improvising a recipe versus following it exactly.
That's a great way to put it. Another category was the agentic path. Is the plan static and predetermined, or is it dynamic, changing based on new information? And finally, they looked at repetitiveness. Does the agent solve the problem in a single shot, or does it take multiple steps, refining its approach as it goes?
Okay, so they created these categories and then ran tests on 5 different real-world AI agents. Agents designed for chemistry research, question answering, and even software engineering. What were the main takeaways?
Well, the first big one we already mentioned, the CPU is the main bottleneck, taking up to 90% of the latency. The second takeaway comes when you try to scale things up. Say you want to run hundreds of these AI agents at once. This is a measure of throughput.
Like how many tasks you can get done in a minute.
Exactly. They found that your throughput eventually hits a wall. Either the GPU runs out of memory or the CPU gets totally overwhelmed. This happens because of something called oversubscription. Imagine you have 8 workers, or CPU cores, but you give them 32 jobs to do at the same time. They spend all their time switching between tasks instead of actually working, and everything grinds to a halt.
And what about energy consumption? We know these systems can use a lot of power.
That was the third key takeaway. When you're running these systems at a large scale, the CPU's energy use becomes a huge factor. It can be responsible for up to 44% of the total energy consumed. So making the CPU more efficient isn't just about speed, it's also about sustainability and cost.
So the paper identifies a major problem. Our CPUs are holding back the next generation of AI. Did they propose any solutions?
They did. They came up with two clever scheduling optimizations. The first one is called CGAM, which stands for CPU and GPU aware microbatching.
That's a mouthful. Let's break it down. What's microbatching?
So normally, if you have 128 tasks, you might just throw them all at the system at once in one giant batch. But that causes the CPU traffic jam we talked about. The researchers found that the performance gains really start to drop off after about 64 tasks. So with CGAM, they cap the batch size at this optimal number. For that job of 128 tasks, they run it as two smaller, more efficient microbatches of 64.
And running two small batches is actually faster than one big one?
It is for the people who submitted the first 64 tasks. Their jobs get finished in about half the time. This is fantastic for systems that might offer priority service. On top of that, it uses less GPU memory and saves a ton of CPU energy. It's a win-win-win.
That's CGAM. What was the second solution?
That one's called MAS, or Mixed Agentic Workload Scheduling. This is for situations where you have different types of jobs running at the same time. Some might be really CPU heavy with lots of tool use, while others are LLM heavy, meaning they need a lot of GPU thinking time.
So MAS is like a smart traffic controller for different kinds of AI jobs.
Perfect analogy. Instead of treating every job the same, MAS intelligently allocates resources based on what the job actually needs. It stops the GPU-heavy jobs from hogging CPU resources they aren't even using, which frees up the CPU to focus on the jobs that really need it. This makes the whole system run much more smoothly when it's juggling a mix of tasks.
So the big picture here is that as AI gets smarter and more capable of taking action in the real world, we need to broaden our focus beyond just the GPU.
That is the core message of this paper. To build the truly powerful and efficient AI assistants of the future, we have to look at the entire system. It's not just about the star player, the GPU, but about how the whole team, especially the often underestimated CPU, works together in perfect harmony.
A fascinating look under the hood at the challenges and solutions for building the next wave of artificial intelligence.
That's all the time we have for today. Thanks for tuning in to Daily Papers.